Hello and Hare Krishna. Welcome to Chasing Reality with me, Ryan Bissett, aka Ramananda Das. Today we'll be joined by Professor Bob Ulanowicz, who is based at the University of Florida. He is author of several books, one of which is A Third Window, Natural Life Beyond Newton and Darwin. So Bob is a process ecologist, and I am excited to ask him questions all about what is an organism. It's something that I took totally for granted as I was studying, although I found it fascinating hearing in biology lectures and later in my PhD studies, I'm like looking at the different molecular mechanisms of organisms and the different pathways and how crazy complicated it all is. Now I'm beginning to question, I'm kind of going back to the beginning and saying, what actually is an organism in the first place? So, please stay tuned for lots of interesting discussion with Bob Ulanowicz today. Well, thank you for joining me, Bob.
It's a pleasure and an honor, Ryan.
So I understand that you're an expert in, is it ecology or process ecology? Have I got that right?
Yes, well, I was trained as a chemical engineer, but I spent my entire career as a theoretical ecologist. And I discovered that theoretical ecology didn't entirely fit the domain, and I carved out for myself a niche called process ecology. The idea is that ecology is more amenable to process thinking than to physical thinking, which is essentially objects moving according to universal law, whereas ecology is all not about the objects as much as it is about the relationships and the processes between that go with those relationships.
Okay, so then I have to confess, I'm not an expert in philosophy. One thing that I found recently is that I understand there used to be a classical education, if that's what it's called. So people used to be trained in natural philosophy. You know, you understood
Right.
science and philosophy was one thing. Whereas I feel like I've been kind of shortchanged there. So if you could just help
You and me both. Yeah.
Okay, well, I think I was reading some of your work, and I think you could definitely help to illuminate on the point of what is process thinking? Because it keeps coming up a lot actually in biology right now, systems
Right.
thinking and process thinking.
Yeah, process thinking, it starts with the idea that events are most important. And what a process is, it is a series of events, an historical series of events that is essentially irreversible. These processes can link with one another, and it's what I call configurations of processes. Now, the question is, why is this so important to living systems or thinking about living systems? And the example, the metaphor that I like very much goes back to my dear departed friend Enzo Tietzu, who owned an estate near Siena. And Enzo was also a thermodynamicist, but he grew olives and grapes. And he was always being depredated by deer. So he got so mad one time after an attack by deer that he grabbed his gun and he went out and he shot a deer. And he goes down and he looks at the deer, and he, of course, being somewhat of a thinker and a thermodynamicist, he says, what's different about this deer right now than it was 90 seconds ago? And he said, it has the same mass, it has the same molecules, the same genes, the same bound energy, all of these things that we normally think of in conventional science. What's missing? And of course, the thing that's missing is the coherent configuration of processes that really define the deer as being alive. And I think that bears down on the importance of processes and coherent configurations of processes in the study of life.
Thank you. That's a very vivid example with the deer. I've often heard, you know, when people see their loved ones pass away, and it's obviously quite a shocking and devastating moment for them. And they say, well, you know, the person is, it's like that they're still there, but gone. And obviously this can get into the idea of the soul and these kind of
Mm-hmm.
things. But I'd like to understand how the concept of living organisms being processes differs from that kind of maybe traditional religious idea of an entity causing a body to function.
Yeah. Well, first of all, there's a branch of theology that looks upon belief in God, that God is more of a verb than a noun, that God is being and the ground of all being, so that we use metaphors for thinking about God, because no one can truly comprehend God. We use metaphors. Many people have the idea of childhood, of an old man with a beard and whatnot, Leonardo. Um, uh, but really, when it comes down to it, the Greeks had this word homoisis, the idea that God was being, and that in the Trinitarian thought of things, that God was one unity but three persons, and that there were relationships among the three persons. Of course, that's getting kind of narrow in Christianity, but it's always been there, I think. It's just that it's difficult to talk to people, especially young children, in terms of just being and whatnot. So we have to make up metaphors. But at least me in my later life, my later religious life, I tend to think more in process terms, and the idea of God supporting the entire universe with God's being. Now, soul, the truth of the matter is, the whole idea of configuration of processes and soul, it's kind of hard to distinguish between the two. And the big question is, can this configuration of process exist somehow outside the body? Well, that's also a problem in consciousness, the theory of consciousness. Many people say that consciousness doesn't all reside in the brain, that it actually resides also in the relationships you have with other people and society around you, and that even if your brain and your body should disappear, that somehow that residual goes on.
Okay, thank you. You mentioned the word consciousness, so I'm particularly interested that I'd like to pick up on it. When I think of consciousness, I'm coming from a background where I've trained in biology, realized, as I said to you, that I felt a bit shortchanged, went back and studied a little bit in more kind of Eastern concepts, you could say.
Mm-hmm.
And one thing I noticed is the definition of consciousness that I'm used to is that kind of like Descartes in a sense, but when he said that I think therefore I am. So that a conscious entity, I can't maybe say what I am, but I can say that I perceive, I experience, as David Chalmers termed it, qualia. I experience the qualia of the world. I don't just experience electrical signals that my brain is dealing with. It's a different currency that I'm dealing with, something qualitative. Are we in line there with the definition of consciousness? Or?
Yes, and I think you put your finger on it, that you said a different thing. It's as an engineer, I always deal in dimensionality, and living systems differ from non-living systems according to time. There's processes involved, explicitly involve time, whereas the laws of nature, believe it or not, laws of physics, are to a degree timeless. There's always something, conservation of matter, conservation of energy, conservation of momentum, etc. And time is really a secondary thing, but in processes, time is very important. As far as consciousness goes, I have my own leanings. I don't think anyone truly understands what consciousness is, but the physicists, if I may borrow from physicists, have this idea of a coherence domain. For example, they've discovered that water, especially water in living systems, doesn't just exist as random water molecules, that there are these aggregations of about 100 water molecules apiece. And they're held together in a coherent form, more or less coherent form. And the big question is, how does this cohere? Because in order to be coherent, it can't depend on the the bonding between them, because that only occurs at the speed of light. There has to be something that's faster, and as we know, nothing really can go faster than the speed of light. Well, what the physicists have said is that yes, phase velocities in the quantum vacuum can go faster than light. So what they're saying is that there's quantum phenomena that holds it all together. It's a very weak sort of a thing, but it's enough to coordinate all of the molecular bonding, just the way a coxswain would coordinate the rowers in a boat, if you will. Well, other people have tried to apply this to ecology, for example, and say that, okay, we have these transfers of material and energy, but they occur rather slowly. How are they coordinated? And the answer probably is something through information. You have visual, you have olfactory, you have sensory information, etc. And that all of these, although they're weaker than the actual transfers, can serve to coordinate everything. So I would like to take this one step further and say that in the brain, okay, we have neurons communicating with one another, and the average time of communication is about 1/10 of a second, rather slow in electromagnetic terms. But when you have a firing, you also have a very weak electromagnetic pulse, and you have them all throughout the brain. And I say that it's very possible that these electromagnetic pulses, although they're weak, can bring the brain into coherency. So, and that gives us this feeling that everything is at once. You know, right now you're experiencing visual signals, perhaps auditory signals, et cetera, but it all seems to be at once, because I think it's, you know, the brain is more than just sequential firings of neurons. It's coherent action of neurons. So that's my take on consciousness.
Okay, so you're saying that that's what I think you're saying is that the brain, the way that the brain functions, it presents information in a unified fashion.
Yes.
So that I'm experiencing. Okay. I want to go more into the ecology, but well, that's an interesting term. I'm going to ask you to find that in a moment. While we're on this topic, I understand information is being presented through the brain. What I'm wondering is, do you think we can explain scientifically who or what the observer, experiencer of information is? Because there seems to be information being presented for I say that I'm observing. I see myself as always being the same in my life, in the sense that I can observe my thoughts, my mind, my personality's changed, everything's changed, but I seem to think I'm me. And I'm just wondering, can we approach that scientifically?
Well, I think it's possible. I don't have it worked out, but I think it's possible. And part of that I talked about in a third window. The idea is that okay, first of all, when you have coherent firing of neurons and so forth, it's usually because there are mutually beneficial routes through your brain, okay, that they're sort of self-reinforcing. Whenever you have self-reinforcing and mutual beneficence, it gives rise to something called centripetality, or in this case, centrality, I think, is what you're concerned about. The idea that a coherent set of processes will draw resources that it needs to function into it. Of course, this is a fundamental process of life that almost nobody ever talks about. Okay, it's centripetality. But I think in terms of a neural manifestation, that there is this image of centripetality, or a center, an ego, an id, that comes about as a result of this coordinated neuronal firing.
Okay, I think I understand. So you're explaining that that it could be that this kind of experience of a central experiencer or observer could come about through emergence through brain activity. Yes.
Okay. Yes, okay. Yes. Now it's emergence, okay? It's not determination. I'm not of the Churchland crowd who say that the brain is a machine and that we can explain everything through the individual firings of neurons. There is a coordination that has occurred and has come about historically. We each have our history, we each have our experiences, and it's unique to each individual. And that there is an agency involved in this coordination that is to some extent decoupled from the individual firings of the neurons. We're not just machines. That's my personal belief.
Okay, so we're not machines in the sense that the brain it's not all deterministic.
Yes.
There's some flex or play in the thing.
There's free will, to an extent, obviously.
Yes, and I've been hearing recently from a very interesting theory from Professor Stuart Hameroff in Arizona University. It's to do with microtubules and quantum events within microtubules as a way to try and explain consciousness. I guess what I've been struggling to kind of pull together with this, and what you were just saying is, to me, to have free will indicates that there is an agent that has it. But if the agent's always changing, who is it that has the free will? It's a real headbanger. I don't know if you've got any.
It is a headbanger. You're right. Yeah. Who is it that has the free will? I think we have to. Okay. First of all, the theory that it comes from microtubules and so forth is sort of classical, bottom-up explanation and whatnot. Right. As an ecologist, I believe that those phenomena are important, but they're not the full story. That we indeed, as you go up the hierarchy of events and complexity and so forth, that higher level phenomena are capable of causation as well back down. So that it does go both ways, and that the higher level entities can affect those at the lower entity. Now, you get into a problem that's called supervenience. How can it possibly be that something that was created from below can have control back down? And right. that was a real problem for me. A fellow by the name of here I'm getting a senior, Daniel Dennett, had a metaphor for evolution. He said that evolution was cranes built upon cranes. The idea is that you have a crane that emerged, and then it pulls up the resources it needs for a crane on top of it, and so forth, up and up. I didn't like that metaphor. It's so too mechanical for me and too one-dimensional for me. And I was working in the garden. This is the only eureka experience I've ever had in my life. Okay, and I was working in my garden, and I suddenly saw in the corner a muscadine grape that I had planted about 10 years ago. Now, muscadine grapes, they grow in humid climates like the American Southeast and whatnot. But the idea was that I planted this grape. It put up a trunk, branches, grapes. Okay, as usual, just like the vinifera in the colder climates. But the muscadine grape also puts down adventitious roots from its branches. In other words, it drops these root-like things to the ground, which then enter the ground and create roots. And what had happened here was that the original trunk disappeared, and the grape was being sustained by the adventitious roots. And I said, aha, here it is. It's a metaphor, okay? It's not a strict analogy of the metaphor, but the idea is that you have these phenomena that create something above, but the thing that above can actually can seek out new pathways, new routes, new modes of action that replace what originally caused it. So you have this two-way flow of causation. That's the way I look at it.
That example is really nice, and I think I've heard it in another way, and maybe there's a classic way of looking at it. Maybe you could help me with this. The idea that there's if you look at a bottle and you've got some gas molecules in there, the gas molecules are being constrained by the bottle. So I've heard it put in a, I think it's a process ontology sense of at the cellular level, for example, it's not that, as Barbara McClintock said, DNA is an exquisitely sensitive, she said, not an instrument of the cell. I forget the exact words that she said, but basically the notion was that the cell is, it's not that DNA is determining the cell is using DNA for its purposes. Is that what you're...
I couldn't agree more. I couldn't agree more. The idea is that the DNA is a material cause. You know, in the sense of Aristotle, he said there's material, efficient, formal, and final causation. And that they're material causes, but material causes are generally passive, okay? So that DNA is a material cause for the being, but the real action, the real efficiency is in the proteomic and enzymatic reactions that are occurring around the DNA. They read it, they edit it, they do various things with it. They're the activity, and that we should be focusing on. So I couldn't agree with her more.
Okay. Then if we take that cell example, it seems to... The example that was given in a more recent work, I think it was by physiologist Dennis Noble, and I don't want to quote him, I might be getting it wrong, but this is the idea that I understood, is that function and purpose emerge from lower levels of complexity. And so when I talk about the purposes of a cell, I can't really maybe understand exactly what's happening at the cellular level unless I look at a higher level. So if I look at the tissue level, then maybe I've got more of a kind of understanding of what could be happening. So what I was trying to understand is, and I think maybe you can help with this because you seem to be on a similar vein, is that what's being said, that purposes and functions, they're not in the cell they're kind of emerging. So the cell is almost using what it's got in like molecules and DNA and proteins, and that's an emergent function, or has the cell always had a function and purpose? I'm not sure if I've explained that right.
Okay, the function and purpose are two different words. Function we can talk about, non-cognitive things, but purpose generally is something that's almost, at least, well, alive or almost human. Okay. I do think that purpose and direction come from at the upper level. They don't necessarily come from below. And the reason I say this is that function and purpose is the result of a self-reinforcing set of processes which has grown or evolved according to contingencies. Let me sort of back up with all of this. This is my little mini lecture and so forth. Suppose we have three processes, A, B, and C, such that A benefits B, B benefits C, and C benefits A. Okay, so it's what we would call autocatalytic. That sequence, that dynamic gives rise to selection. Okay, suppose there's a change in B, and suppose that change in B makes it more sensitive to A, then it will be a better catalyst to C, and that will come back around to B. It will be self-rewarding. Okay. Conversely, suppose something happens to B that makes it less sensitive to A, it will get less return from A, when it goes back around. So there's an asymmetry in all of this that favors mutual beneficence. Okay, let's go one step further, and then I'll get to your purpose and whatnot. One step further is that these processes don't just exist in a vacuum, they need resources. And suppose there's a change in B that helps it to bring in more resources, it will be rewarded. And the same is true for A and C. It's true for all members of the configuration. And what that gives rise to is a centripetality. The idea that as time goes on, more and more resources are drawn into the dynamic and the ambit. Okay, centripetality. Now, what I didn't emphasize was when I say suppose there's a change, okay, that is a contingency. It's a contingency that doesn't necessarily have to come from, the lower elements of the construct and so forth. It can be something that happens to it. It can be a new resource that comes into play or something like that. And it happens in an arbitrary fashion, okay? The same thing that selects, well, the selection will select for contingencies that benefit the configuration and against those that do not. So that what you have is an historical progression. The system starts out fairly simple and it begins to incorporate contingencies from its environment and historically so that what you have at the top is to agree independent of what started it all. Okay, it's the result of external contingencies that can't be controlled by those things below, but the configuration will gradually ratchet up on them, and that so I think that the purpose, really arrives at this higher level, semi-autonomous level, rather than from below. That's my picture of it all.
Okay, that's very nice. And the key word there is one that I'm struggling to pronounce: centripetality.
Yes.
I got it right?
Yes, that's right. It was coined by none other than Sir Isaac Newton. You have centrifugality, things being thrown apart, and centripetality are things being brought in together. Yeah.
It's very nice. It's very vivid. And when you said about resources gathering, yeah.
Let me emphasize, I feel this is a major necessary factor of life. Go look at the people who list the attributes of life and so forth. See who lists centripetality. I don't know of anybody that does outside of rogue scientists like myself. But we know it. We know from actual experience everything has to eat. We go out and we see. In nature, we see coral reefs that to somehow bring all these resources from this desert of an ocean into this rich environment. Centripetality exists all around us, anywhere you have life. It's a fundamental property of life, but nobody's treating it.
That's very interesting because I'd never heard of it. It's not something I'd come across. So I wanted to ask you, what would you, if you were going to write the textbook on life for students who are up and coming, I'm not sure what age, but maybe before they've heard too much about it from biology, how would you like to present the information to them about life and these kind of questions in biology?
Okay, this has actually been done for me, believe it or not. I had a colleague, an Indian colleague, who read A Third World, and he said that he was going to try to introduce it to a bunch of high school students. And I thought, well, good luck with that, because I'm having trouble convincing my fellow ecologists that this is worth. Well, fortunately, he had some very bright daughter and niece and so forth, and one of them actually has created a booklet about process ecology as recognized by a high school student. It's marvelous. I can send you the URL to it.
Please, yeah, that's fantastic.
Let me make a note to do that. URL of oh, this is terrible. I'm having a senior moment. I've forgotten her name now, but I will send you a URL to it because I was amazed when I read it. I thought this is wonderful. And my problem is my wife always says you need to give more actual examples, and it's true. I tend to think in an abstract way without lots of examples. And in order to get things across, especially to younger people, you need to have a lot more examples. I'm gradually getting them, but I'm nowhere near where I'd like to be.
I know what you mean, and sometimes it takes other people as well who are more kind of strong in that way to take people, as ideas like yourself who are able to kind of really generate those ideas and put them into examples.
Okay, the student's name that just came to me is Yashari Himinskaya. It's Yashree. But I will send you the URL, and it's, I think, a very good attempt by a 15-year-old lady to young lady to 15. Yeah, it just blew my mind. It totally blew my mind. So that, it can be done. I may not be the person to do it, but it can be done.
Hmm. Can I ask you, so your book, I mean, your main book has been, I think it was 2009,
Yes.
Third Window, Natural Life Beyond Newton and Darwin. What are you hoping to, what do you think the issues are with Newton and Darwin, and maybe we're not so aware as young biologists and maybe young scientists of the kind of history and philosophy and how it gets carried into the actual, what we're learning and what we're studying?
Yeah. Okay. I think the thing to do is to look at physics from the outside. Okay. What many people don't realize is that there are some constraints on physics. Okay.
Mm-hmm.
Physics always looks at the world as objects moving according to universal laws, and essentially they can be dead objects. They don't have to be live objects moving according to universal laws. And it's very difficult, I believe, to make the transition to life. How does life come out of dead matter, so to speak?
Sure.
And what I think is that if we remove ourselves from objects and rather look at processes, the transition is much easier. And this was taught to me by a famous ecologist, Howard T. Odum. Odum said that before there was life, before there were cells, there was probably a proto ecosystem. What did he mean by that? He said that there were probably regions of space, maybe in the water or air, wherever else, where you had two different competing reactions, like oxidation and reduction, for example, and that you have physical transport between connecting the two regions and so forth. This creates essentially a thermodynamic engine, if you will. It creates a feedback process if you have a source of energy that is a circular process, if you will. Things are being oxidized and reduced, and so forth. Okay, now what he says is that there can be a transition from a big cycle to smaller cycles. These occur naturally. They occur all the time. They occur in the atmosphere between big hurricanes and smaller tornadoes and cells and eddies and so forth. That's a very natural thing. That you have, you may have certain other smaller mutual beneficent cycles that feed off of this larger engine, and that eventually become encapsulated and small, and you have the proto cell. This is a very different scenario than the idea of having something, the normal mud in the sun hypothesis, that you have the sunshine shining on the mud and suddenly things just get up and live. I call this Ezekiel's vision. Ezekiel had this dream whereby these dead things just assembled and got up and started dancing. And and it's very difficult to square with nature. Whereas the idea of large cycles of action giving rise to smaller cycles is very natural. And that's why I think the process viewpoint is so much more natural. It accords so much better with living systems than does these dead things moving according to universal law. Not that they're unimportant; they are. They do, participate in everything, but they participate more by way of constraint than they do agency or direction. They don't determine. They constrain, but they do not determine.
I see. So these things at lower levels constrain, but they don't determine what's going to happen at high levels. That's a very nice catchphrase. I'll remember that one. That's very useful. I was just thinking to myself as you were speaking that it sounds very reasonable that things, I mean, we see that, as as we look and we see intuitively that things are determined at more kind of higher levels. And so maybe not determined is the right word, but philosophically, but higher levels seem to dictate to lower levels more often than the other way around. And I was just wondering, what is this philosophy you're discussing? Has it a basis in the kind of probably the ancient Greek world, and Darwinism and Newtonian physics? Are they rooted also in? What I'm getting at, I guess, is did the ancients think of everything, and are there cycles of these different theories coming through, and who's right?
Okay, I go back to Heraclitus, which I think he's about 800 BC. I'm not good on my history of philosophy with dates and whatnot, but Heraclitus said that what we see around us is the result of essentially a dialectic. It's things are being built up, things are being torn down, and that they're opposing, but their interaction is what gives us reality that you're trying to capture in the series of discussions and whatnot. So that I think the beginning was right there. Later on, you got the Platonic view of essences, that things are essences that appear and they're unchanging and whatnot, and things approximate them, etc. And our current science is really a derivative of the Platonic Platonic view of the world. It's Neoplatonism writ large, I believe. And what I and some other process thinkers are suggesting is that okay, that's well and good, and it gives us part of the story, but we really need to look at processes and events, because that's the only way we can get into life and truly comprehend life. Now, I'm sorry, you asked me something else, and I got
No, that was perfect. That was I was just wondering how, in what kind of ancient philosophy perhaps your ideas might be rooted, as well as more kind of newer ideas, Darwinian evolution.
Right. Okay. Good. Darwin. Let's take Darwin. Darwin, his original, and I'm not a Darwin expert. Okay, I don't pretend to be, but as I understand it, Darwin posed evolution essentially as a transaction between growth and elimination. Okay, and it was more or less an equal ponderant relationship. Post-Darwin, what happened, I believe, is an attempt to go back to more materialistic roots and focus on genomes, for example, and whatnot. And in that, the whole business of growth essentially got de-emphasized. So that now natural selection is only elimination, and it occurs from outside the system. That's the neo-Darwinian viewpoint. I and others, I don't want to take full credit for this, are positing, people like Dennis Noble and whatnot, are positing something rather different. That in fact, growth is very much an equal partner in all of this. It's not just elimination, it's not just entropy, but rather you have this endogenous selection. It's not all from outside, it's from within the system. This endogenous selection that causes growth and causes development, and it selects for development. And it reestablishes, I believe, the equiponderance between Heraclitus's building up and tearing down. Because we've essentially done away with the building up. We look, because it seems too mysterious to many people, okay? But it's far easier to talk about elimination. We see it all the time. The world is full of terrible things. So that we've developed what people like John Haught would call a cosmology of despair, that everything is just elimination. And I think we need to go back to the way Darwin originally started this, as an equal ponderant transaction between growth and elimination. Newton, of course, and Newton, okay, to go back to Newton has been interpreted differently than Newton intended himself to be. Okay.
Okay.
We always think, what's Newton's second law? If you had asked me 20 years ago, or as a graduate student, what's Newton's second law? I said force equals mass times acceleration. You know, it's just a sort of shorthand that everybody uses for it. Well, it surprised me enormously to learn about 3 years ago that Newton argued strenuously against this presentation. That in Principia, Newton came up with what we now call a difference equation, you know, delta T. He really didn't take the limit to infinitesimal time and space and whatnot. That was done by a fellow by the name of Leonhard Euler, who was a compatriot oh, this is terrible, the famous German philosopher. But anyway, Newton said, no, we cannot make the infinitesimal assumption because it equates cause with effect. Cause and effect become simultaneous. And he said cause has to be separated from effect. Well, we've kept that assumption in almost all of physics. The four major force laws of physics are all reversible. What does it reversible mean? Okay, my example for that is, not original with me, but is two perfectly elastic billiard balls coming together and bouncing off one another. If you take a motion picture or a video of that, and if you run it backwards, you can't tell which way is forward and which way is backward. That's reversibility. And that all four laws of physics are reversible, okay? But we know we live in an irreversible world. Sadi Carnot in 1820 told us that. And that caused an incredible amount of consternation amongst physicists because they had this classical Neoplatonic form of conservation throughout the world, and here's something that's messing it up. And it took physics about 50 to 60 years until Ludwig von Boltzmann and Josiah Willard Gibbs came up with a statistical mechanics that purportedly showed how you can go from irreversible laws at the microscale, from reversible laws at the microscale to irreversible phenomena at the macroscale. And everybody said, okay, that's settled. Well, yeah. I say, no, it wasn't settled. Okay, the reason being that if you look at the assumptions that Boltzmann and especially Gibbs made in order to come to that congruence, they're extremely narrow. There's something called the Ergodic Hypothesis, and they use what's called an ideal gas in which the tokens do not affect one another at all. Okay, there's no interaction between particles.
Oh, I see.
It's very, very narrow. Okay, and they found, and then they made some assumptions like they introduced stochasticity and so forth, and said, voila, now we can marry them for this very, very narrow set of circumstances. And then they said, okay, that's settled, and we haven't really gone back to it for about 130 years. We've just accepted it. But if you look at Popper and his school of falsifiability and so forth, the idea is that we should always be looking to tear apart our theories, because that's the only real test that we can make of a theory is try to falsify it. It's the exact opposite. It's totally the opposite. We find one tiny little thing and we generalize it to all of the universe. And unfortunately, those self-same models give rise to a number of other philosophical endpoints, like the heat death of the universe and whatnot. Well, anyway, I've gone on too far, perhaps.
No, I want you to keep going.
but the idea is that physics does have certain constraints. Physics is very much a part of the story. I'm not saying that the physical laws are violated. They're not violated, but they deal in universal variables, and the real world deals in micro constituents which are very variegated and therefore extremely high in combinations and number. Okay, so that the laws of physics truly constrain, but they under-constrain what can happen in the real heterogeneous world. Physics is all about homogeneity. A fellow by the name of Walter Elsasser back in '84 quoted Whitehead and Russell, 1913, as showing that all the laws of physics the four forces laws of physics can be reduced to operations on homogeneous sets. Right. Homogeneous is very much a fundamental part of the foundations of physics. Biology is heterogeneous. Yeah. It's massively heterogeneous. And the combinations between them are so enormous that there's always a little bit of wiggle room, if you will, for life to get around certain constraints. Yeah. That's the simplest way of putting it, I would suppose. Stuart Kaufman says that, well, another way of putting it is that the laws never stand alone. The laws of physics never stand alone. If you ever apply a law of physics, you've got to do so by making certain boundary constraints. So the boundary value problem, initial conditions or boundary conditions. And it's only the combination of law and the boundary value problem that if they're both well formulated, then you have determinism. Okay, and that's easy to do in simple systems. But once you get systems with quadrillions and quadrillions of quadrillions, literally, of combinations, there's such a density of possibilities that one can no longer determine, that the laws themselves are no longer determinate. They constrain, but they're no longer determinate. Of course, that leads to the questions, what does determine? And I've already talked about that earlier. That's when you get this historical succession of contingencies that are frozen into self-reinforcing dynamics. And there's where the real agency lies. And it lies at the higher levels. Okay. I'll be quiet now for a while.
No, thank you very much. That you really helped to clarify so many points there. Many things that struck me, but there was one, because one of my questions, which was going to come out of this, is it sounds like this is what we should be talking about. It sounds to me like this is the conversation. And I was wondering why is it not so much? I've seen some discussions, almost kind of underground. There's various websites, the Third Way of Evolution, with I think quite a lot of process or systems biologists, and then. But you said something. You said because it's a bit mysterious, and it's just. I think you said it's because it's. Maybe too complicated to study, or what do you? Yeah.
Well, it's not determinate, and people want a determinate world. Many people have a great deal of difficulty living with uncertainty, and Ilya Prigogine said we live in a world of massive uncertainty, of extreme uncertainty, and we do have order creating processes, but they're not, they're not eternal, so to speak, and that bothers a lot of people, I think. And unless you anchor yourself somewhere else, which a lot of people don't want to do, it's hard to deal with that uncertainty. That's one dimension of it all, I think. The second dimension just has to do with inertia in thought, in the sense that we have a structure that rewards thinking in a certain vein. And suddenly, people really don't want that to be turned over, because they get their grants and whatnot, and you just don't want it. So I think and then there's this other thing, that there are many people who are wedded to this cosmology of despair, in the sense that, for reasons that many of them very understandable, okay, for reasons of their own, they don't want anything that's transcendental, because it might be a slippery slope to God, and they want to keep it out of the conversation. Don't get me wrong. I have great respect for agnostics and whatnot, and I can, but I really feel that anyone who thinks, whether they're a theist or or an agnostic, anyone who thinks that we can rationally work our way out of that big question, does God exist, is simply fooling themselves. I think, you have to at some point make an assumption, a personal commitment to one way or the other. And people do, and a lot of people have done it and don't want anything that's transcendental encumbering science.
When you say transcendental, are we referring to, are we referring to something that's metaphysical or genuinely? Because obviously metaphysics is something that's kind of making a comeback, and I'm
Right.
just wondering, when you say transcendental, do you mean something that isn't physical? Or isn't
Okay.
an emergent property of physical? Yeah.
Okay. First of all, transcendental can be quite elemental. In mathematics, we talk about transcendental functions, and like a logarithm is a transcendental function, and rather than a proportion or something like that. So it can be something rather simple and rather familiar. But I'm talking about the fundamental assumptions. Who was it? Who was the famous Viennese philosopher? Popper and he had a big to-do at one point. Anyway, that's one of the problems of growing old, is that you forget things that are very familiar to you. But anyway, he said, what are the real questions we should be asking in science? And he tended to slough off everything as just being a problem of linguistics. He says, unless we're talking about unless we trace everything back to the very fundamental assumptions, that might be interesting. And that to me, when I say metaphysics, I'm not talking about the metaphysical world out there. And so I'm talking about what are the fundamental assumptions. And there's been very few attempts to outline the metaphysics of conventional science. Bruce Weber and David Depew in Darwinism Evolving tried to do that, and they came up with 4 or 5 assumptions. What were they? Closure, atavism, determinism, reversibility, and universality as the fundamental assumptions that helped us through the 19th century and the big burgeoning growth of physics. And what I try to do with a third window is try to define an alternative set of fundamental assumptions that was more friendly to life and to living processes. And I came up with 3, and I don't know where to attribute this. Somewhere in my ancient brain, I came across someone who said, there are 3 things that I need to get, you give me 3 things, I'll give you life. He says, give me chance, and I would say, I wouldn't say just chance, I would say contingency, because that's a more complicated version of chance. Feedback and memory. Those 3 elements, and I'll give you life, okay? And what I came up with was essentially 3 postulates that were a paraphrasing of that. I came up with contingency, and I don't use chance because chance is always associated with blind chance, and there are other forms of chance, okay? There are very few arbitrary events that are truly blind chance. Okay, contingency, and I come up with feedback and especially autocatalysis, in other words, mutual beneficence, and then memory. Now, everybody, when you say memory, they immediately think of DNA and RNA, and of course, they're superb examples of memory. But I believe, and I think a number of other people like Terry Deacon believe that DNA was actually a product, an exaptation that emerged out of the earlier biochemical life processes. And that once it appeared, that it was probably something like an energy carrier, because RNA, I think, has certain energy carrier attributes and whatnot. It's probably something like an energy carrier that was exapted. In other words, it evolved under one set of circumstances, but then suddenly proved useful in another theater. It was exapted to become memory. And once once it was exapted, it was so much better than the early forms of memory, which I'll talk about right now, that it just extirpated everything else, so that all living things contain DNA now. Okay, what do I think the early forms of life had as memory? I think the actual structure, the structure of the processes tends to be very stable. Okay, and that served as an original form of memory, that you had these configurations of processes that were pretty stable, and they were in themselves their own memory. And it wasn't until they developed essentially RNA, DNA through exaptation that it extirpated everything else, and everything else became totally secondary.
Excuse me, exaptation, I'm not sure what that means.
Okay, exaptation, it's something that some evolutionary theorists talk about, where you have a character that is developed for some purpose in one theater. The classical example, I think, is the swim bladder in fish. Okay, if you go, and I'm certainly not a paleontologist, but apparently I'm told if you go back through the fossil record, what you find is that that fishes started to develop lungs, and that at one point those lungs evolved. I mean, they developed this vacuole in themselves, and in some of them they became lungs, and they crawled out and land, and we have all these land mammals and reptiles and so forth. But in other fishes, it was exapted to become a swim bladder. You know, it's essentially a vacuole within the body of the fish that the fish can contract or expand to regulate its position in the water column. So that's sort of the classical example of something that was evolved for one purpose, but suddenly there was this other environment, and it was exapted to serve another purpose in a different environment. Okay. And that's what's meant by exaptation. I probably don't do it justice because I'm not an evolutionary theorist.
Thank you very much. We've been speaking for about an hour now, so it's gone so quickly. It's been an incredible discussion.
I've enjoyed it very much. I am grateful to you for this opportunity, because I don't get a chance to talk. You said, why isn't this the conversation now? It's not, and it should be. I'm not necessarily what I'm saying, but people like Dennis Noble and Stu Kaufman and a lot of others are saying we really should be thinking about more seriously.
Definitely, and it obviously has valid roots and methodologies, and it's something that can be. It's one thing that I've wondered. We obviously live in a scientific world where you typically have one overarching paradigm, and I've often wondered if it's just something to do with our psychology. Why is it not possible for many different paradigms to exist at the same time and do science? But it doesn't seem to work like that, and I can't help but think it is a psychological thing.
Yeah. It's also paradigms conflicting with one another. No, I agree. You're talking about pluralism of paradigms, and a good practitioner of that was Sven Erik Jorgensen, who was the editor of Ecological Modeling magazine. Many of my publications were in his journal simply because he was a pluralist. He could think of different paradigms existing next to one another. And obviously you get total confusion if everything, but I really think that we need to entertain a few other paradigms close to one another, because they're not always totally contradictory. There's a lot of overlap among them, and where they overlap, we can have good conversation. Where they don't overlap, we can start testing each other. I really think we need a little more pluralism.
And I think friction often arises when there's pluralism, and that can sometimes be a really good thing. There's a lot of creativity that can come, and an idea generation when things seemingly collide, as long as people are willing to have the conversation in the first place. But fear is, I think you mentioned it, fear of so many things on a human level, grant applications, it's just difficult. So I understand.
Fear of uncertainty.
Yes, fear of uncertainty.
Well,
Would you like to just as a kind of closing remark, I'd be interested to hear your thoughts about where you would like to see science go, and maybe not just science, but maybe any trends you've noticed in world affairs, or and how it's all linked together.
yes. World affairs. They're kind of shoddy state right now. I think we need. Okay. It was a developmental biologist by the name of Sidney Brenner who said, who took apart this little E. coli bacterium that had something like I don't know 129 genes, and tried to map each gene to a trait or a behavior and whatnot, and he failed. And he says what we have to do is we have to understand how lots of things are put together in the same place. And I think not enough attention is being paid to that at all levels of society, not just in the scientific world, but also in the, in the larger socio-political economic world. I mean, what we've discovered, for example, with ecosystems is that ecosystems don't design themselves for maximum efficiency. And yet we go around all over the place trying to maximize efficiency everywhere. And that doing so, in certain cases, can lead to collapse and destruction. This is another thing that's come out of this way of thinking that's gained a little bit of popularity in the economic field. Bernard Littier, who just died a week ago, unfortunately, was a very big proponent of this. Anyway, we have to reinvent a lot of our social mechanisms to take cognizance of things going together, the world being totally related. That's why I think that ecology is, the title of my second book was Ecology, the Ascendant Perspective. That was a play on words. Ascendant and ascendancy was a mathematical function of networks. But I really do think that we need to marry physics and ecology in order to have a more ascendant view of the world. Maybe that should be that may be my coda.
Thank you very much, Bob. I'll go and get my new hat for the marriage of physics and ecology.
Okay, first rate. Oh, good luck with it, and I again thank you very much for this opportunity.
Oh, thank you. It's been really nice.
Okay, thank you everyone for listening to this podcast today. I had a lovely discussion with Professor Bob Ulanowicz, who is not only a very learned scholar, but also a gentleman. He dealt with my questions very sincerely and very gently. I can appreciate that I was out of my depth. This is my first recording, my first interview, and I've been out of the lab for a number of years. Truthfully, even if I was still in the lab, I still think I would have been out of my depth, because Bob is very expert in physics, mathematics, and clearly history and philosophy of science. And that shone through. It was very nice, and I hope you all got a lot out of this recording. For myself, I think I need to do a bit more homework and a bit more background research. I don't think I'm ever going to really be an expert in those more mathematical subjects. But the essence of what I got from this is that organisms aren't just their parts. They're complicated things, and so are ecosystems. We can't look at them in a mechanistic way. There needs to be a new way of understanding, almost like a new physics of biology, to be able to understand organisms and their environments within a systems framework. So this is a topic that I'm fascinated in. I'm clearly not qualified to go into the details, but I still think an important question in all of this is, if there is an organism and it experiences the world, I know I do, I assume you do as other human beings,
we're understanding more from animal behavior studies that other kind of so-called lower species do as well. Obviously, we can't really understand their subjective experience, but the question I'm particularly interested in is, can we understand what an organism is for? Is an organism an emergent property? Is that what an organism is? And how would we go about proving that purposes emerge from a system? How would we prove that? Versus what I would propose is that organisms, the conscious entity, is utilizing its body, its physical body, and I would say mind, in order to, like a virtual reality suit, a very exquisite and highly refined one, in order to be able to experience and enjoy the world in a certain way. How would we differentiate those two hypotheses between emergence and maybe the VR model, if you want to call it that? So I'm going to brush up. I'm going to do my homework, so I'm a bit more clued up next time, and I can ask better questions. And hopefully next time we speak, Bob, I'll be able to bring out even more juice from our discussion. Thank you all, and good evening.